Hello, everyone, and welcome to this new Arduino Cloud Café. This is the second episode of the series, and if by any chance you missed the first one, I would encourage you to give it a view. You can find the link on the screen of our Arduino channel, so you will find there the link. In that session, we introduced Arduino Cloud and chatted with Sakin, an enthusiastic influencer. And we are not going to introduce today the cloud again, so I think it should be a good starting point for those who are not familiar with Arduino Cloud. Our goal with this series of Arduino Cloud Café is to keep our community of users regularly updated about news on Arduino Cloud and to have the chance to chat with relevant people about some topics that I'm sure that will be of interest for all of you. Today we are going to speak about environmental monitoring and why it matters. And we are super excited to have two special guests who will share with us their insights, experience, and projects. So without further ado, let me introduce to you our guests. I would like to introduce Christian first. He's part of the cloud development team, and he's a usual participant in our webinars. He's behind the scenes, helping answer your questions during the presentations and during the Q&A session. Hello, Christian.
Hello, welcome everybody.
Next, let me introduce Bill. He's a former electronics technician and systems analyst who has been working with electronics since the mid-70s. He loves working with both hardware and software, and he currently teaches microcontrollers and electronics on the Dronebot Workshop website. He also runs a YouTube channel and other channels in different social media. And let me say that his channels are extremely popular, with an astonishing number of more than 500,000 subscribers. So we are really excited to have him with us today. Hello, Bill.
Hello, David. Thank you very much. I'm also very excited to be here.
And we also have Muhammad. He's a senior software engineer with more than 14 years of experience working on web-based and IoT systems. And apart from being content creator, teacher, and IoT evangelist, he's also a book author. And we are really happy to announce that he recently published the book Arduino IoT Cloud for developers. We will speak about that later. Hello, Muhammad.
Hello, everyone. Thank you, David.
Okay, and if you want to win one digital copy of the book, okay, the only thing that you have to do is to leave a comment on this live stream video on YouTube. At the end of the session, we will randomly pick 5 lucky winners from the ones who left comments. If you are chosen as a winner, we'll reply to your comment. Please then reach out to us with your contact information to claim your prize. So, yeah, please tell us whatever you want in your comments, what aspects of environmental monitoring interests you, and yeah, be positive, insightful, and reflect interest. That's what we actually expect. So yeah, what are we going to speak about today? The topic for today is environmental monitoring. We will explore how the Internet of Things is transforming environmental monitoring, enabling us to collect, analyze, and understand critical environmental data. We'll deep dive into various applications of IoT-based environmental monitoring too. And our guests and myself will show some examples. At the end of the session, we will have a section where we can answer all of your questions. Okay, this event is streamed via LinkedIn, Facebook, and YouTube. So please use the comments on the platform that you are using to ask your questions. During the webinar, we will try to answer them all, but don't worry if you don't see them answered, as we will try to read them out loud during the Q&A section at the end. Okay, so let's get started. Environmental monitoring plays a crucial role in safeguarding our planet and ensuring our well-being. By continuously collecting data on various environmental parameters, we gain insights into the health of our ecosystems, enabling us to identify and address potential threats, protect our health, and promote sustainable practices. Okay, so let's explore why it matters. I will focus on 2 main broad concepts that actually lead us to smaller ones. Let me start with weather monitoring. Weather monitoring is a fundamental aspect of environmental monitoring. It provides valuable insights into precipitation, temperature, humidity, wind speed, and other meteorological parameters. IoT-based weather monitoring systems offer several advantages over traditional methods. First, we get real-time data with these IoT sensors continuously collecting and transmitting data, and so enabling real-time monitoring and forecasting of weather conditions. We also have wide coverage, as IoT sensors can be deployed in remote and inaccessible areas, expanding the scope of weather monitoring. And these applications are also very cost-effective, as IoT systems offer lower operating costs compared to traditional monitoring methods. And what kind of applications can we create using IoT weather monitoring? It is actually, if you think about it, the cornerstone for modern agriculture and gardening. Okay, so that's quite straightforward. You can not only optimize irrigation scheduling based on the weather and soil conditions, but you can also manage optimal crop periods or other land and plants management tasks. But weather monitoring can also be applied to home automation. You can create automatic adjustments to heating, cooling, and ventilation systems based on predicted weather patterns, for instance. As an example, it's very popular to control the blinds or the awnings depending on the amount of sunlight. Or for instance, in relation to awnings, it's very important to shut them if rain is expected. Another typical use case of weather monitoring is renewable energy generation. Whether you are a home producer or a company generating electricity, you must always look at the sky to optimize the performance of solar and wind power plants and take the weather conditions into account. And we also have air quality monitoring. Air quality monitoring is a crucial thing for detecting and addressing air and water pollution, as well as potential health risks. If you think about it, IoT-based air quality monitoring systems offer, on the one hand, high sensitivity, as IoT sensors can detect small concentrations of gases, providing early warning of potential leaks or pollution events, but they also provide remote access and real-time data from IoT sensors from anywhere. But we also get data analytics. Okay, so these IoT systems can identify trends, patterns, anomalies, and provide valuable insights for pollution control and risk mitigation. For instance, during the COVID pandemic, the use of CO2 meters gained a lot of popularity. At the end of the day, detecting high concentrations of CO2 was a very smart way to detect that the place was not ventilated enough and had a higher risk of virus transmission. So some of the applications of IoT air quality monitoring are pollution levels tracking in urban and industrial areas, and water quality monitoring, and of course, health applications, as monitoring gas concentrations in indoor environments or also in outdoor environments. So summing up, what are the kind of benefits that we get from these kind of applications? Nowadays, protecting our environment is not just an option. It's a pressing responsibility for each one of us, okay? And technology comes to the rescue with these kind of applications, as they enable us to use the natural resources more efficiently. We can combat pollution, prevent environmental degradation, and minimize our overall environment footprint. Moreover, the implementation of real-time monitoring enables the establishment of early warning systems for natural disasters or extreme weather events and other critical situations. Another important thing is the positive impact on our health, which is clear too. Whether it is mitigating pollution or measuring indoor gas concentrations, a lot of applications contribute to that. But for those who are more pragmatic, it's worth noting that there are substantial cost savings associated with the implementation of these systems. This extends from everyday applications, where optimizing home automation leads to energy savings, but also to larger industries and other sectors. But if the practical benefits aren't compelling enough, there is an undeniable benefit for the hobbyists and tech enthusiasts like me, for instance, because implementing these kind of solutions provides an exciting opportunity to learn new technologies and have a great deal of fun. Okay, so it's a win-win for both our curiosity and enjoyment. Okay, but this is not a matter of myself pitching you about environmental monitoring. We have two guests with us, and I would like to get their thoughts about the topic. So yeah, Bill, I would like to get what do you think about this, and why do you think that environmental monitoring matters, and what are your thoughts about the topic?
Well, David, as you've already pointed out, it's a really essential thing. Environmental monitoring and keeping track of trends will show you things like situations that are getting better or getting worse. Air pollution, for example, is not something that you can see, but if you can monitor trends in air pollution, you might be able, for example, to find a source of pollution that you weren't aware of and stop that source before it gets worse.
Yeah, absolutely. And I think that this is also not a matter of creating applications for large companies or enterprises. I think that each of us can contribute. I mean, there are many networks of sensors, distributed sensors, and applications that can contribute to these kind of things. Okay, so to
Yeah.
monitoring coverage and so on. And Muhammad, what's your take on this topic? What are your thoughts about why environmental monitoring matters? What are the main benefits, use cases that you see?
Yes, already you and Bill pointed out the main things. And yes, it is a human nature that we need some sort of indicator to take the steps. And in underdeveloped countries, especially in underdeveloped countries, we didn't have any tool to measure the pollution. But if a young generation use the technology, sensors, and cloud technology to monitor their environment, then they are able to convey their message into their territory as well as to their government officials to take the steps to protect the environment. Because right now we are spending our life, but if we didn't take the steps, it will destroy our future generation. You can say that there are new disease coming due to the environmental pollution, and maybe we are spending our life very good, but our future generation face the new sort of diseases. So it's time to protect the environment.
Yeah, I absolutely agree with you. And you have said something very interesting because I think that, I mean, this is probably not related to environmental monitoring or IoT environmental monitoring, but of people and community of people driving transformation of things. Okay, so
Yes.
I mean, at the end of the day, we are speaking about health. Pollution, of course, is a very important health issue in many countries and these large cities that we have nowadays. So I think that people leading this kind of transformation, just creating their own applications and forcing their governments and so on to make an impact. So I think that that's also very important. Okay, thank you very much. We will deep dive into some of the use cases that you have prepared for us later on. Okay, so yeah, I will jump now to one specific use case that we have been working on after this generic introduction. Yeah, probably most of you already know Sparkman, which is basically a gadget shop for electronics thinkers. It offers parts, kits, and learning resources to help you build your own electronic projects. And they resell many products, but they have many products developed by themselves. One of them is a weather station kit. This kit is very, very popular, okay, as it is. It collects a lot of information at a very affordable price. And some months ago, as the result of a cooperation between Sparkman and Arduino, we presented an integration between the weather station kit from the Sparkman weather station kit and Arduino Cloud. The idea of this joint development is to simplify how to use the kit so that users don't have to develop the firmware and the control plane. They can just deploy with one click the firmware on the microcontroller and get a ready-to-use dashboard. Okay, so this is done through an Arduino Cloud template, which is a very cool feature of the platform that allows you to deploy things with to deploy software and dashboards with one click. Okay, and then later on you can modify them. You have all the code accessible for you and the dashboards. I don't want to spend a lot of time because I want to see what Bill and Muhammad want to show, but I wanted to show to you what it looks like, this panel. So this is an example of a running weather station kit. It is in our office in Malmo. The people there have been playing with it, so I don't know if it is actually indoor or outdoor right now, okay, but I know that they have been playing with it these days. So we can see the evolution of different parameters here. Okay, so this is a very interesting use case. And then ultimately, all this information can be used across all your different projects. So you can use this information to control your blinds, to control your awnings, or just for fun, okay, to get notifications about something, or if you are using a garden or whatever. So yeah, coming back to presentation. Sorry. Yeah, I will now shut up and we will jump into Bill's section so that he presents his projects. Bill, the stage is yours.
Well, thank you so much, David. And welcome, everyone. For those who don't know me, my name is Bill, and I have a YouTube channel and website called Dronebot Workshop, where we work with a lot of Arduino stuff, including the Arduino IoT Cloud. And with the stuff that I do, if you're familiar with my videos, I always start off with a little bit of an explainer to tell you what it is we're going to be working on. So I'm going to do that. Essentially, what you're going to be seeing is a project that I'm developing. It is a cloud-based project for indoor environmental sensing. It's not finished yet, but I do have some of it working. So we'll take a look at the presentation, and then I'll show you some of the hardware and the dashboard for the project that I'm building. So let's take a look at this right now. The project that I'm presenting today deals with another type of cloud, a cloud of pollution. Pollution is enough to make you sick, and it can cause or augment several serious health conditions. There are several forms of pollution. Ozone, which is a gas that can trigger chest pain and throat irritation. Particulate matter, which is a mixture of solid and liquid particles in the air. Noxious gases such as carbon dioxide, carbon monoxide, and sulfur dioxide, and volatile organic compounds like benzene, formaldehyde, and methylene chloride. There's no doubt that our air quality in general is deteriorating. Pollution is responsible for 6.5 million deaths per year worldwide. Air pollution can originate from both industrial and natural sources, and we can divide it into two categories: outdoor pollution and indoor pollution, and my project deals with indoor pollution. It may be your home sweet home, but your house is actually a source of many types of pollution. And if you think you can mask it all with an air freshener, well, that's a source of pollution as well. Indoor pollution raises a number of red flags, and it's not to be taken lightly. It has some serious side effects. But we can fight back and take action with technology, and that's what I'm going to do today. We're going to be obtaining data from a number of different sensors. We'll be monitoring to find the current status of our air, the historical status to see if it's improving or degrading, and of course for alerts to deal with immediate situations. And then we'll react. We can react manually, and this can be something as simple as opening a window, or automatically, such as turning on a ventilation fan. The project I'm building will be working with the Arduino IoT Cloud. I'm going to attach an air sensor unit to the cloud to measure a number of different parameters in the air. We can monitor all of this with a cloud console, and if there's a serious situation, we can send alerts to a mobile device. The air sensor unit is built around an Arduino Nano ESP32 board, and it has some common and readily available sensors attached to it to measure particulate matter, VOC index, temperature, humidity, and air pressure. On the cloud console, we'll be able to display volatile organic compounds, or VOCs. We'll display particulate matter, and we'll be able to display it in 3 different levels: PM1, PM2.5, and PM10. The number after the PM refers to the size of the particles in microns. We'll also be monitoring temperature, humidity, and air pressure. These are values that are necessary for human comfort, and they can also augment certain situations such as the growth of mold. When we have an alert, we'll be using triggers, a relatively new feature of the Arduino IoT Cloud. Triggers will allow us to send a push notification, and that notification will be received by the Arduino IoT Cloud app on our phone. Another addition to the system is a gas sensor unit built around an Arduino Uno R4 Wi-Fi board. This sensor will use 3 gas sensors, and as these are 5-volt sensors, they can take advantage of the 5-volt architecture of the Uno R4. It also can drive an exhaust or ventilation fan through a relay. The final configuration is shown here, and it will consist of multiple gas sensors, multiple air quality sensors, the console and the alerts monitor, as well as a direct connection into the Amazon Echo Home unit, and a connection through If This Then That to both the Echo and to the Amazon air quality system. So the next time the cloud of pollution enters my home, I'm going to be fighting back with the Arduino IoT Cloud. And here I have one of the air sensor units on a solderless breadboard. And this is the one based around an Arduino Nano ESP32, which you can see over here. I've got two of the sensors over here. This is the temperature, air pressure, and humidity sensor. And this one is the volatile organic chemical sensor. And these are both I2C sensors, and that makes hookup very easy. And of course, I can and probably will add more sensors for additional parameters. Now, this sensor up over here is for particulate matter, and it connects in a bit differently. It's a serial sensor, and as the ESP32 has 3 UARTs, we're just using one of the serial UARTs for it. And it's an interesting sensor. It's actually got a fan and everything in it, if you can see the top of it over here, where it collects in the particulate matter. And now I'm displaying all that stuff on the screen, and I'll show you that in a second. But first, I want to show you the other board I've got. Now, this one isn't live at the moment, but it's the gas sensor that I showed you a little earlier. And this is the one based around an Arduino Uno R4 board. You can see I've got 3 of these MQ gas sensors. The MQ gas sensors are 5-volt devices, and that's why I chose the Arduino Uno R4. The nice thing about the MQ sensors is they make different ones for different gases. So I've chosen 3 that are relevant to my environment. But of course, if you live in a different environment and have different gases or different situations, you could just replace them with other sensors. I've also got a relay on this and a tiny little fan. Now, in the real life, of course, it's not going to drive a tiny little fan. It's going to drive a big one. But this just will allow me to test it. So I'm going to bring the other board back in because, as I said, it actually is up and running online right now. At least I think it is. And we'll take a look at that board right now. Let's just see. And now here is the dashboard for everything, and I think you can see what's what. Up in the corner, we're reading temperature, air pressure, humidity, and the VOC index over here, and that's volatile organic chemical index. And here I've got a running total of the VOC index. I can take a look at it live. Right now I'm taking a look at a 7-day period. Incidentally, this long line over here was basically when I was playing with the thing and had it off. Now, if you go to the bottom, you'll see we're reading particulate matter, and we're reading particulate matter at 3 different levels here: PM 1.0, PM 2.5, and that's kind of the standard, and PM 10. And you can also see a graph here. And for this, I've used the advanced graph, which is a really neat widget that the cloud has. It actually lets me have 3 axes on it. Let me just expand that a bit so we can see it a bit better. So you can see there's actually 3 different axes on this graph, and it's reading the PM1, PM2.5, and the PM10 stuff. Now, this stuff is also going live, but it only registers anytime something has changed. That's one thing with the Arduino IoT Cloud. When you're making cloud variables, you can set them up to either change when there's a change in data, which is what I've done here, or you could just have them sample periodically, let's say once every 5 seconds or something. What we're going to do right now is a little demo of the particulate matter sensor. And what I'll do is I will get a little pollution going here because we haven't got enough pollution in the workshop right now. So let's just see if we can pollute this place up a bit. Okay, and I've got a soldering iron over here, and it should be making some particulate matter for me that should be starting to register soon. And I'll make this go down a bit. And I actually should be getting a register. I'm not sure exactly why I'm not. Let me just reset this thing. I've had a problem with it. Just bear with me for a second over here. I've love it when the live demo goes bad. But this, oh, no, actually, I was just impatient. I'm sorry. It's working just fine. I had an issue a little earlier where I had to reset this thing. I thought that might be the case, but I'm just a bit impatient. And as you can see, the particulate matter is really going up. In fact, it's probably not even safe for me to be here in the workshop. But a monitoring system like this is something that I want throughout my home. And basically, we had a real incident here last year. We had what I'm sure most people in North America know is we had fires in northern Canada that drove our air pollution up to extreme levels. And I was fortunate in that I do have several air cleaners in my home. I also have monitoring equipment, so I was able to keep the air really safe in here. But with something like this, I'll be able to continually monitor the air in my room, in my home, and make adjustments when necessary. As you saw, I've got additions to it, so I can start adding fans for both ventilation and exhaust. And so it can automatically keep track and control some of the air in my room. And I think that will be a great thing. So basically, that is my project.
Thank you very much. It was extremely cool to see it in action. So yeah, while you were presenting, I was thinking about a couple of things. So you were speaking about the benefits in your home as a home automation system, but I can also see many many use cases related to other places, offices, hospitals, and these kind of things. So
Sure.
what do you think?
Oh, absolutely. I mean, really, air quality monitoring, I think, is something we all have to be aware of now. It's just like, back when I was a kid, the only thing we looked at in the weather was the temperature. What's the temperature going to be the next day? We didn't even look at humidity back then. And I'm talking way back in the 60s and that. And then finally, they started adding humidity into forecasts because people wanted it. Now, when you look at weather forecasts, at least around here, they also give things like the air quality indication, the VOC index, the amount of PM 2.5 in the air. It's becoming more of the standard weather forecast because people are just more concerned about it, and rightfully so. It really does affect our health. So hospitals, schools, any place would be an ideal place for something like this.
Yeah, I agree. And most of our viewers, I'm completely sure that will be interested in learning where are you going to have the code and the instructions to set this up. So where
Oh,
are
of
you
course.
going to have this?
Oh, of course. Well, actually, a couple of places. Like what you're seeing is a preview of something I am building for the Dronebot Workshop. So naturally, there'll be an episode about this. And I'm also going to be posting this into the Arduino Project Hub as well. And naturally, schematics and code and everything will be included with it.
Yeah, Project Hub is a really nice place to find for high quality projects that you can replicate. And after using the Arduino Cloud, what do you think is the best feature or the feature that you have used more and has solved you more issues and has made your life easier?
Well, I think really the way the dashboards are created is really great because you can whip up a quick project and it's very easy to whip a dashboard up for something like that. Once you have the concept of things like things, cloud variables, and dashboards down pat, you can really do this stuff really, really quickly. Setting up an IoT project is very fast. You just introduce a new device into the cloud. If it's an Arduino device, it's very easy. And as long as you don't lose that secret code they give you when you set it up, you're all set. You can get the thing running in a few minutes. So I like the idea that you can take something from concept to design really, really quickly with the cloud.
That's basically in the DNA of Arduino at the end of the day. So to make things easier for the users and to help them create things very quickly. Okay, and just a curiosity, are you an old school guy using the Arduino IDE, or have you given a try to the Arduino Cloud editor?
Well, obviously, I'm an old guy. I used both for
I
this
said old
project.
school guy, no,
Yeah,
not old
I
guy.
heard that. I heard that. um, I did use both for this project. I started out with the cloud editor, but I have to tell you something, and it was just, maybe it's me, maybe I just missed it, but I ended up switching to the IDE 2.0 because there was a feature I couldn't find in the cloud editor that I needed over here. Now, maybe, as I said, it's me, and I just didn't see the feature, but specifically when working with the Arduino Nano ESP32, In the IDE, you have the choice of using either Arduino pin numbers or legacy ESP32 pin numbers. And there's a selection for that. I couldn't find that selection in the cloud, and I actually needed it because of one of the libraries I was using. So I moved over to the IDE 2.0. So I guess you could say I'm still an old school guy.
Okay, but you gave it a try, so that's nice.
Yeah.
Okay, thank you very much for sharing your insights. So yeah, let's move now to Muhammad, and he will show us what he has been working on related to environmental monitoring and his insights and projects.
Thank you, David. The build project is awesome and good, but every bigger thing starts by taking a smaller step. So, in my session, I will tell you how you can get started with the Arduino IoT Cloud and how you can monitor the temperature and humidity, because I think it is the first step to get started with the environmental monitoring. So here I'm using the MKR Wi-Fi 1010, including the DHT22, and I'll just show you a smaller setup. Here I have just connected the DHT22 with the MKR 1010. Actually, I used this sensor and development board because these are easily available in all over the world, and especially the new students or professionals who want to immediately get started with the Arduino IoT Cloud are good to go to use these things. Okay, so we have only three pins of a DHT22, which is one is 5 volt, other is a ground, and the third one is a out. You can say that data pin, which is connected to the digital pin number 7. And all the documentation and code has been included at the Arduino project hub. You guys can watch that, and now it's time to get started with that. Arduino IoT Cloud have a different plans, but you can immediately start with the free plan, where you have an option to create two things. I have right now maker plan, so I'm able to create 25 things. So just we need to click on the things, and here we have a thing option. Just click on that. the the thing I love about Arduino IoT Cloud is that the thing is a conceptual container which holds all the cloud variables, your network configuration, your device, and even a sketch. And if you and the other feature is over the air update. So now our page has been open, and firstly we need to assign the name to our thing. We can say that temperature and humidity mkry 5 10 10. Okay, and now it's time to add the variables and temperature. And by the way, it is a very good thing that Arduino provides us an extended version of cloud variable types. Like I can use the float, but they have temperature in both centigrade as well as in Fahrenheit. So I'm going to use this variable type, and we're giving the permission read and write on change, and we're good to go with this. And the other variable is humidity, and here we need to find out the humidity, relative humidity, which measures all the thing in the percentage. And it's a setup. Now it's time to add a select a device. Actually, already I have MCAR Wi-Fi 1010, so I'm going to use this one. But if you didn't have any device, you can click on the set up a new device, and you will find a wizard. And another thing is that you should have Arduino Create Agent on your machine, because without Arduino Create Agent, you are not able to select your device. By the way, it will also show you an option if there's a Arduino create agent is unavailable at your machine. So I am selecting that machine. So yes, detaching. So by the way, it's already attached with another thing. So it's a rule and regulation that we need to detach the thing. Okay, so here we need to configure our network. So here's my SSID, and here's a password, of my uh, Wi-Fi network. Okay, and here's the sketch tab. And if you see here, we can also methods regarding on temperature change as well as on humidity change. And they also mention the temperature and the humidity for the reference person that we are going to use in the code. Okay, so if we come down to the code section at Project Hub, you just need to copy the code and just paste it here. And it includes all the DHT and necessary libraries that are going to be used by the Arduino IoT Cloud. Okay, the one good thing of the cloud editor is that you don't need to worry about the libraries. By the way, sometimes I get stuck at Arduino IDE because I need to download and install the libraries. But when you are using the cloud editor, then you are good to go and you don't need to worry about the stuff. Okay, so here I need to select the port MCAR Wi-Fi 1010, and we're going to click on that verify and the upload. And if you guys are using a DHT11, then you need to change the type to DHT11. And if you are using another digital pin like 654, then you need to mention the digital pin over here. Rest of the things are good to go. So this code will send the values after every 20 seconds. It will take just a couple of seconds. Now it started uploading the code to the development board. Oh, congratulations. Now here we go. And here we will see our values. So I'm just going to, again, I need to give the name. I don't know, temperature and humidity. Okay. So at that time, what we will do is now it's time to create a dashboard to visualize our values. So that's why I opened another dashboard page into another tab. Already we have a dashboard, but now it's time to add a new dashboard. Click on the dashboard. Just assign the name to your dashboard. And from here, I will use a different type of widgets to demonstrate. So here we have a value as well as gauge and the percentage. So frankly speaking, I love the gauge to show the temperature. So just give it the name temperature. And now it's time to link cloud variable. So here is, I think, our device name. I don't know why it's not updating here, but soon I think it will reflect the changes. Okay, here we need to select the temperature, and we see here right now we have a 21.6 value here for the temperature, and we are going to link that and we're good to go. Okay, so click here done, and now it's time to add percentage for our humidity and link the humidity. And if you see here you cannot select the temperature because I think it takes the value into percentage or some sort of like this. Okay. The good thing is that we can display the icon, and I'm going to use this humidity icon. What do you guys say? This will work or this will work? I think it is good for the light, but I'm going to use this for the humidity. Okay. And here we can also set the threshold to change the colors. You can explore this thing. Okay. Now, we can also resize our things like this way. And okay, and if you want to resize more like this, then we are good to go. Okay, done. So now these are the two widget controls, but you can also use the charts. Here we have two types of charts. One will be used to display the simple value like the one metric temperature, and we're going to go. So here we have an option to use the line or simple. So I'm going to use the line. And next, I'm going to use the advanced chart. Here you can mention the multiple columns like temperature and the humidity, temperature and humidity, and link the both variables like humidity and the temperature. It is good to compare the multiple metrics at the same time in a real-time environment. Okay, so we are good to go with OK, and I'm also going to use another chart for the humidity. Variable, and we are good to go. Again, I'm going to use, now it's time to drag and drop here and just do this. Awesome. Now we are done. And if we click on the view side, so here we're able to watch all the values. So now you guys understand that how it is easy to get started with the Arduino IoT Cloud, and how it is easy to create a beautiful dashboard and add a different types of widgets according to your requirements. Still, Bill already talked about the cloud triggers. It is easy to just set the threshold and get the notification on our mobile device or at a desktop PC. So this is my demo, and we are good to go. And by the way, in the real time, I just uh, put the sensor into my uh, hand, and now the temperature is changing.
Thank you very much, Muhammad. I think that you actually showed very well what Bill was describing earlier about how easy it is to create the project, because in just a couple of minutes, you created a project from scratch, okay, from the definition of the thing, the device, the variables, and the dashboard. So that's precisely what's the strength of the platform, that you are able to show your data in a very quick way. Okay, so yeah, I was thinking about which are the next steps of of your project. Okay, so what's actually the evolution and the next steps that you are thinking about this application that you were
Yes,
creating?
actually, I have a plan to integrate the MHZ19 and 16 sensor to monitor the carbon dioxide, as well as there is another sensor, MQ135. It is a good to go to monitor a short range of air pollution, I think from 1 to 1000 ppm. But I'm working on MHZB series to monitor a huge carbon dioxide, to monitor a bigger impact in industrial areas as well as at indoor, where if we talk about for example about the classrooms, there are 60 to 70 students in a one classroom, then these sensors will help out to monitor carbon dioxide at a bigger scale.
Okay, thank you very much. And okay, I would like to also take this opportunity to speak about your book, okay, the Arduino IoT Cloud for Developers. I think that there have been some questions in the comments about this. We will share some, well, we have here the links in order to purchase the books and so on. And remember that we have this, if you can leave your comments, and then you can win one of the digital copies of that we are raffling today. Okay, I have a couple of questions about the book, because the book is actually a very complete guide of the platform. It starts from the very beginning as the basics, and it gets to the more advanced features, okay, like APIs or command line interface and the Cloud CLI, which are the advanced things of the platform. So what's actually the kind of audience that you were trying to target?
Actually, there are audience who belongs from the electronics or electrical side, and they want to get started with the IoT, but they don't know about the clouds. Then this book is specially designed for them. And some guys who are already working in the field of web development or web application or mobile application, and they want to work on the IoT cloud integration, then this book is also for them, because we have an API section. And the beginners who are blank and really want to start the IoT, then they are also targeted in this book.
Okay, thank you very much. So yeah, just a quick reminder of what I said. Please leave your comments about the about the topic that we are speaking about today, and you can win one copy of this book. And as we are very tight and over time, as usual with these kind of events, let me just go to the end of the webinar. Okay, so very briefly before wrapping up, let me show to you which are the latest features that have been added to Arduino Cloud since the last episode of Arduino Cloud Café. In our last event, we introduced that the UI had been completely reworked. Okay, we basically, with this renewal of the UI, we made it easier to use. Okay, so it is more user friendly, and we included many features that were asked by the community. So this was basically the result of the community feedback. And as you know, okay, this renewal has been done in several steps. Okay, so in January, we announced the renewed cloud editor. In December, we announced the new UI and the new mobile app 2.0. And now in January, we have announced the new cloud editor. Okay, and this new cloud editor brings several things. Okay, first, it mimics the experience of the Arduino IDE, so that the experience for the users is more similar to the one that you may have using the traditional Arduino IDE. This is something that we discussed briefly with Bill. And yeah, just remember that using the cloud editor is optional. It is, I mean, I think that it is a very cool editor if you want to work from anywhere, but it is, of course, you can keep using the Arduino IDE to develop your cloud applications. And also, instead of having two editors, as we had with the previous version, now we have just one. And from a technical point of view, this new editor has a new framework, okay, that prepares it to have more advanced features and more cool features that are coming soon. So stay tuned for upcoming updates. Okay, the former web editor is still available until the end of March. Okay, and starting from April, the new editor will be mandatory. Okay, and what else? Many other things have happened during this period of time. So we have renewed both our documentation and projects portal, Project Hub. That's something that we have been mentioning during this session. Both are now, I think that they are easier to navigate, basically, and the information is easier to find. And next, in relation to the cloud, we are now supporting ESP32-based templates, okay? And that's something important because that allows us to have a template like the one that I described earlier, the SparkFun Weather Station one. But you can also find the Blink template, which is the hello world of the templates related to ESP32. So it's basically the first thing to get started with. And additionally, there has also been a very interesting update in the advanced chat widget. Now it is possible to aggregate data based on different criteria. Okay, so if you are interested in more information, just go to our documentation section and our recent announcements, and you will find more information there. Okay, and that's it. Before jumping into the Q&A section, I want to remind you that, as usual, we are also offering a voucher for 1 month free of the Maker Plan. Okay, so with this voucher, you can enjoy all the advanced features of the platform. So please scan the QR code or use the coupon code LoveCafe, and yeah, and then you can redeem it in our cloud site and upgrade your account. And this voucher will be valid until March the 13th. Okay, so now it's time for your questions. So let me go to the list of questions that I have here. Some of them, I guess, that have been already answered by Christian. Okay, and some of them probably are for our guests. So let's see. There was a question about what's the name of the book. The name of the book is Arduino IoT Cloud for Developers. Okay, you can find it in Amazon. We have shared the links during the session. There was a question. I want industrial peer sensor to use in a home automation project. Does the Arduino company provide ones beside educational or laboratory sensors? As far as I know, no, we are not providing any specific peer sensor. I don't know, Christian, if you know about that, but I don't think so.
No, I suggested to check. There are many nice peer sensors from other vendors, but
Yes.
of course you can integrate them in an Arduino project usually very easily. So probably it's a good option to buy the sensor you want with the specification you want, and then integrate it into the Arduino project.
Yeah, there are definitely many interesting projects that you can find in Pearl Hub, Hackster.io. So I'm definitely sure that you will find some use case using that you can use as a reference. There was a question: will it be designed to detect all kinds of gases? I guess that this was something that was asked during Bill's presentation. So I don't know, Bill, if you have any answer for that.
I'm sorry, what's the exact question? I didn't quite.
The question is, will it be designed? I guess it is your project. Will your project be designed to detect all kinds of gases?
Well, as I showed, I think you're probably talking about the MQ sensor side. They make MQ sensors for a wide variety of gases, and I think there's about maybe 20 or so different gases you can get. I would suggest that you put in the ones that are relevant to you. A good example is natural gas, for example. My home is electrically heated, so it's not very likely I'm going to be detecting natural gas. We don't have it over here. But if your home is heated with a furnace powered at natural gas, naturally you'd want a sensor like that. Same goes for things like carbon monoxide, etc. Some people may or may not be susceptible to that. So I'm going to put in as many gas sensors as are relevant to myself, basically, but I don't think I'll be sensing every single gas.
Thank you very much. There was another question from Raimi Douglas. Does Arduino Cloud work with ESP now? I think, Christian, that you answered the question. I don't know if you want to expand the answer. I can also give some insight about it.
Basically, ESP Now is supported by our Arduino Nano ESP32 board, which supports also the Arduino Cloud. So I don't know if you are brave enough to try to both connection, but ideally the purpose of ESP Now is different from the purpose of the cloud. The cloud is for possibly a huge amount of data, while ESP Now is for a small amount of data. So on the other hand, with ESP Now, you can connect directly with a peer-to-peer protocol, two boards to each other. So probably you can open a channel towards the cloud and then try to connect another board with it. Anyway, again, Arduino Nano ESP32 supports both,
it. Yes,
both
absolutely. This is actually a very interesting question because this is something that we discussed internally some months ago. And we were planning to create a use case with Arduino Cloud and ESP Now coexisting at the same time. Because at the end of the day, this is what you are saying, Christian, that you can have this P2P communication. Okay, so this is very similar to the device-to-device communication that we have in Arduino Cloud. At the end of the day, we can use it for similar purposes, but in a different way. So yeah, we wanted to explore that because at the end of the day, we don't want to replace things that are already used by the community. So Arduino Cloud is offering like a different layer to show your data easily and so on. But you can still keep using ESP Now if you are using it if you are using it today. Okay, there was another question. Is it possible to consume MQTT only when using Arduino Cloud? You can also probably answer that.
Yeah, I mean, the Arduino Cloud is based on MQTT, so you can, of course, you can use it. I mean, it's the main way you interact with the Arduino Cloud. Of course, you have to create an account, and you have to create a thing like Muhammad showed. You have to create variables, but from that point on, you can interact with MQTT the way you are used to.
The recommended way to interact using MQTT is not using MQTT directly, but using the libraries that we provide. Okay, so that's going to be much easier if you want to interact using MQTT, so that you don't have to struggle with MQTT messages and so on and so forth. So we have two APIs, the device API and application API. The device API is the one that would allow you to interact with the cloud as if you are a device using MQTT under the hood. Okay, so the application API is to create dashboards and things and devices and so on and so forth. This is very well explained in the book from Muhammad, if you want to give it a look. More questions. I'm mostly interested in air quality monitoring because I live in Torino and unfortunately there is a bad quality air many days. I would create an air quality monitoring to raise awareness to my students. Okay, this is not actually a question, but just a comment. Okay. Can I do GPS tracking on Arduino Cloud using 4G SIM on ESP32? I don't see any option right now. I can send GPS data to cloud using Wi-Fi, but how to do the same when my device is outside? I don't know if I understand the question correctly, but you, as long as you have communication with your modem and it supports GPS, and I guess that you're using serial communication to get the information from your modem, you can use that you can use that information in the cloud. And we also have a map widget so that you can locate the information there. We're working on improvements of the map widget that will come soon too. Okay, so stay tuned for that. I guess that you are speaking about not working using Wi-Fi and using cellular communication. So that's something doable using some specific ports.
Yeah, if I can add something here, if the use case is to use an Arduino board outdoor, you have basically probably the main solution would be to use LoRa protocol because it's the intended usage. Nevertheless, there are a couple of Arduino boards which support GSM, or probably one, I don't remember now on the top of my head, which is the Maker 1400. But LoRa probably is the solution for your use case. And it works. It should be working with all kind of boards, not only Arduino boards.
Okay, we have just 2 minutes left, so I will go quickly. Well, we have 2 minutes left, but we are over time, actually. I want an LED to turn on off using a dashboard switch and a physical switch. If physical button is whatever, even though physical. So this looks like a technical question. We should definitely take a look at the code. My suggestion about this kind of questions is to go to the forum and write in the forum. Forum.arduino.cc is the perfect place to ask these kind of questions. There are always people from Arduino, Christian, myself, and many other people. We are monitoring the forum constantly, and we are replying to these kind of questions. But additionally, you have the community who is backing you up. Okay, so you can. I encourage you to ask this question. By the way, if you don't find your answer there, you can also go to support, to the support page in Arduino.cc, and there is a form there where you can ask for support. Okay, and we will be delighted to support you. Okay, there are many more questions, and I don't think we have time to reply them all. So we will definitely try to do that right after the event, okay? Because we can do that in the comments of the stream. So this stream will go from a live event to a video that you can watch on YouTube on demand. And yeah, we will try to reply to all the unreplied questions there. So yeah, thank you very much. to you all, okay, mainly to our guests today. Okay, so it was a real pleasure to have you with us. Your presentations were really insightful, and I think that you helped many users to learn more about environmental monitoring about how to solve these kind of applications using the cloud. And yeah, and also thank you very much to everyone and for joining us today. And see you soon in the next episode of Arduino Cloud Café. Thank you very much.
Bye.
Bye,
Goodbye.
everyone.